Hunt. I'm going to just quickly read the bio I have here. So Dr. Carter Hunt, Associate Professor at Penn State University, where he's the director of the dual title graduates program in transdisciplinary research on environment and society, also known as TREES. His research focuses on the intersections of tourism, conservation, and community development, particularly in Latin America and the Galapagos Islands. Dr. Carter is a Fulbright scholar and widely published researcher, and he brings a wealth of experience on connecting with scholarship, of expertise on connecting scholarship with impact. So join me to welcome Dr. Carter Hunt. And just to say that this session is being recorded and will be sent to you after the webinar today. So Dr. Carter, you have the floor. Thank you.
Well, thank you very much. Good afternoon, folks. Thanks for the kind introduction. I appreciate the opportunity to share some ideas and perspectives about how to develop competitive funding proposals. And you can blame Ezekiel primarily for this invitation because he took a class with me last year where we covered this topic pretty extensively. But it's something I really enjoy talking about, actually. I feel like it's one of the neatest and most important things we do in academia is seek funding for our interests. And it's about as important skill set to learn as any other you might have as a graduate student, whether you want to work in academia or not, is to be able to track resources to our interests. So I know there's going to be a lot of disciplines represented here today. I'm going to present some information here about how to be competitive with funding proposals for research in particular. I think a lot of those techniques and suggestions will apply to other forms of funding that might be for organizations, for NGOs, and things that aren't research-based. What I plan to do is talk through some of this material and try to distill down common elements and come up with a set of advice that hopefully several of you can benefit from. And I'll certainly try to wrap up with plenty of time for questions about specific interests, specific ideas. So with that, I'm going to share a set of slides via PowerPoint here with you. And you can see a little bit of my affiliations there. I do oversee a transdisciplinary research and environment society grad program. I really enjoy working with grad students in research, probably more than working with undergraduates, but I do also oversee an undergraduate program on sustainability leadership. Both of those programs give me a chance to talk with students from a lot of different disciplines, a lot of different colleges. So hopefully I can provide info to be helpful for you guys wherever you happen to be housed here. And I do a lot of field-based research that may be different than what folks here do, but my background involves a lot of environmental anthropology. So I like working insights. I like learning from people. I like doing a lot of listening and then turning that into information I can communicate back to other scholars. There's a few of the research sites I've worked in along the bottom of the page there. And as was mentioned, I spent a lot of time in the Galapagos Islands in recent years, a place that's really important for unique species that don't exist elsewhere, and also the first World Heritage Site on the planet. So a great place to talk about parks, protected areas, tourism development, community development, and biodiversity conservation. Again, what I want to talk about here today is a little bit of approaches to take towards funding proposals, getting on the same page about different types of funding, different types of research proposals. I'll talk about the common elements, the different funding mechanisms we'll share in the proposals that must be submitted there. And I'll wrap up again, trying to distill that down to some key advice. So what I'll be talking about is stuff that I presented in some class material in the past, such as the class Ezekiel took, also in some other universities where I provided some workshops for faculty as well, including this flyer you see here from last spring when I was visiting a university in Mexico, the University of Monterrey, to talk about similar topics. So let's just get started. I work in the social sciences. I even see a little bit of leftover Spanish in this here. And in the social sciences, we have a range of paradigms we bring to the research. We have the positivist type of research that suggests there's an absolute reality out there, but we also have these other paradigms that are specific to the social sciences that allow for us to focus on subjectivity. So on the positivist side, we often try to eliminate subjectivity, be very objective in our evaluations and our science. But on these other side, on the left-hand side here, in social sciences, we often want to know about those subjective worldviews. We have all kinds of terminology and approaches that distinguish work taking place on these different ends. So in social sciences in particular, we already have a set or what I'll call dialectics, things that are kind of diametrically opposed. And I spent a lot of time, a whole semester, in fact, going through these differences. So don't worry about them so much at the moment. But I'll just want to point out there's different approaches to science, right? There's also different approaches that, in the social versus the natural sciences. So we have what we might call pure science in both of those realms, but we also have what we could call the applied sciences. And as a grad student, I wasn't always clear about these distinctions. But over time, I've come to realize that pure science is stuff that's theoretical and very generalizable and can apply in a lot of different contexts. Whereas applied sciences are often driven by specific problems and specific settings. Sometimes that can be generalized and become pure science, but sometimes it doesn't have that goal at all. It's about specific projects and specific locations. The department that we're housed in, Recreation Park and Tourism Management, focuses a lot on science that can inform management. So there's a lot of applied work here. But I also like to connect my work back to the bigger scientific principles of particular disciplines like anthropology and geography. And sometimes research mechanisms, sometimes funding mechanisms will expect one or the other of these types of science to be proposed. Sometimes we see these distinctions between pure and applied science, both in natural and in social science. And again, here's some of those distinctions repeated. Pure science is theoretical, it's generalizable, it's often driven by hypotheses in an effort to predict outcomes. A lot of that work is underdone in universities, but industries and agencies and foundations and NGOs can often carry out that work as well. Whereas the applied science is very practical, it's contextualized. Sometimes it falls under the guise of evaluation and monitoring, where scientific methodologies are used for those purposes. Again, some of that happens in universities and industries and agencies and foundations and NGOs, also quite a bit in the private sector. As was mentioned in the introduction, I do a lot of research on tourism. So I'm a social science scientist working in tourism. I have background in anthropology. And you could see from a diagram like this, that regardless of what kind of knowledge is being sought in the social sciences, we might draw on any number of other disciplines to inform our understanding of things. So that's what this diagram shows here on the left. And in certain periods in my history as a graduate student and a faculty researcher, I've worked independently on projects. I would call that being a lone wolf researcher, basing myself primarily in one discipline and using that discipline's theory and methods to carry out specific research projects. In some cases, though, I've transcended that and worked on teams with people from several different disciplines. And we can think of that as not the lone wolf, but the wolf pack, people prowling around with their different disciplines and trying to bring those to bear on particular knowledge areas, knowledge needs. And there's even some funding proposals I've been involved with since being a faculty member here that aren't for research specifically, but they're about increasing the capacity for graduate students to do research. So I would call those, the wolf pups, getting together with teams of faculty to provide funding for graduate students. In each of those cases, there could be different mechanisms for funding the research. That's why I'm making these distinctions here right now. Depending on which type of project, then, we want to find the sources associated with those. When we think of pure science, we think of a lot of the stuff that's been under assault in recent months. The national agencies like the National Science Foundation, NSF, the National Institutes of Health, Department of Defense, NASA, NOAA. Those are big federal agencies funding research. The CONACYT that you see listed there is the Mexican equivalent of the National Science Foundation. A lot of countries would have something along those lines. The European Union certainly would. But that pure science can also be supported by public foundations, institutes, centers, etc. Whereas the applied sciences, again, they may be existing standing funding mechanisms, but in a lot of cases, they're much less broad. They're not always funded by national level governments. Instead, they're often funded by agencies, private foundations, NGOs, in some cases, governments and public institutions, but usually to a lesser degree. In the pure sciences, these types of funding will support investigation broadly. They can fund student training, as I mentioned. They can support the creation of teams that can be positioned well to compete for internal seed grants and then compete for external grants. So a lot of times you may see this word seed grant used. That's meant to stimulate and increase the competitiveness of a group of people for external funds. Here in the university, university is very excited to bring in external money because of the additional overhead and fringe that provides to the university. When we're competing for these pure science funds through those federal agencies, it's extremely, extremely competitive. In some programs, there could be dozens, if not hundreds of submissions that you might be competing against for 5 or 6 funded projects. But many of them will have annual or 2-time-a-year cycles for funding. So there can be some regular funding mechanisms to get familiar with in your research areas on the pure science side. That means science that, again, is generalizable across a lot of study contexts. In contrast, on the right side again, with the applied science, it's usually for specific projects. It's often much more one-off in nature. There can be some standing funding mechanisms, but not always. Usually they have already identified a problem for you. Instead of on the pure science side, you identifying a problem and bringing theory and methods to bear on that. Some of these applied science funding mechanisms will already have identified a problem. They're looking for different people's approaches to solving that problem through the research. They're often short-term or finite in length. And they're looking for immediate impact. They're not looking for positioning a team for future success with external funding. They're looking for positioning people for success right now. So they want to see the return on impact more immediately. And in some cases, when these are coming from foundations or government agencies, they might be contracted. Perhaps you already, at some point in your career, will develop a reputation. It might be contacted by people interested in using your skill set on a project. And so when it's contracts, it's a little less competitive. But of course, you must be known by the people looking for help to be contacted in the first place. In any case, these applied science fundings are a little more ephemeral and sporadic in nature. And the approaches we would take to developing the proposals would be a little different. On the pure science side, the theory is often the most important element. How that will read to the research that's generalizable across many contexts. So you start with a theory and you use that theory to develop a problem that needs investigation. And once you've gone through that whole process, analyze data, you publish it. Whereas on the applied science side, we're often starting with the problem. We're going off and collecting data to learn how to solve that problem. And then we often try to see how we can generalize that to other settings, if at all, by incorporating it into the theory, trying to publish it. So that was a lot of info. And here's the most important thing to remember. Whether I'm doing pure science as a lone wolf, applied science as a wolf pack, or vice versa, or whether I'm seeking funding for trainings, conferences, professional development for myself or for other students or for whatever reason, the vast majority of proposals for different funding mechanisms are going to have the same components. That's kind of like the first thing I want to do is sort of demystify a little bit about this. There's going to be similar components to all types of funding mechanisms I just described. It's important to know some of those distinctions and when and where to access certain funding sources, but the approach to writing a competitive proposal is often the same. So let's demystify further the elements that go into those proposals, the common elements that those proposals will always share. And I like this graphic because this is how I'm coming at you with a lot of info. I'm going to keep coming at you with more info. But again, we have plenty of times to clarify this and ask questions. In the process of all this info coming at you, we're going to find out what are the most important things to remember. Okay, so get ready. Here it comes. If I were to submit a funding proposal, in this case, a pure science funding proposal to the U.S. National Science Foundation, which is a big benchmark for scientific quality, there would be a lot of elements that go into that proposal. They could be anywhere from 50 to 80 pages, each one. This is a search page on the National Science Foundation website where you can see the awards that I've been associated with. You can see the first 4 are what are called DDR-IGs, Doctoral Dissertation Research Improvement Grants. And they've been submitted to different programs at NSF, including the Decision Risk and Management Sciences Program, Cultural Anthropology Program, and the Arctic Social Sciences Program. You can see a 5th project a little further down the list that is a project of my own. I would call that a lone wolf project, submitted and funded by the National Science Foundation's Cultural Anthropology Program. And at the very bottom, this NRT Infuse program is an NSF research traineeship focused on food, energy, and water systems. And so that was one of the examples of a funding source, a funding mechanism that supported graduate student training here at Penn State. So it provided fellowships. The one above it was for my own research. The 4 dissertation grants were specifically for student dissertation projects. Regardless, each one of those proposals has a standard format to it, dictated by NSF. Here's what those contents would be. A 1-page project summary, anywhere from a 10 to 20 page project description, depending on the mechanism being accessed. This is the main proposal document. Of course, a list of references. This hopefully doesn't sound too unfamiliar, but then it goes on. And NSF has a lot of other things it requests. Of course, budget numbers and figures in numerical form, as well as text justification of those budget numbers to describe their purpose and what they're being used for. Resumes, vitas, or bio sketches of all participating team members. In some cases, a list of synergistic activities. The vita and the bio sketches at NSF are limited to 2 pages. Many of you are going to have CVs much larger than that. So the synergistic activities is an opportunity to list a few additional things in your background that you'll be able to bring to bear on the project. You'll often have to list current and pending support, all other grants that are currently funding you to make sure there's not conflict of interest or duplication of efforts. Also, along the same lines, referencing any current collaborators or conflicts of interest you may have, people you've co-authored with, people that you're advisors. NSF needs to see all that elaborated. They want to see details of how the data will be managed, how it will be protected, how it will be anonymized, how it will be stored, archived, or made available in open access format in the future. They'll want to see a description of all the facilities where the research would take place. That could include your offices and department and labs here on campus, also other institutions that you may be collaborating with. If there's grad students or postdocs, NSF will require a mentoring plan for each of those individuals. Increasingly, there's what's now called a security plan, especially if we're working in international research settings, to make sure the team is prepared to address security threats that could include the onset of a pandemic or harassment issues of any kind that may take place between team members. And collaboration letters from people that are involved with the research indirectly that may be able to support your efforts. And actually, NSF also allows you to include a list of reviewers to include if you think will review your proposal sympathetically, and those that should be avoided because of perhaps conflict of interest, differences of worldview, differences of research opinion, rivalries, and so forth. So boom, that was a lot of content, right? I told you it was going to be a lot, but we're not done distilling it down to the simple components yet. So that's what we're going to do now. Across all of these items that would make up the 50 to 80 pages of an NSF proposal, this is what would actually look like. There'd be an NSF generated cover sheet. There would be a table of contents. There on that table of contents, you can see the project summary is just a single page. The table of contents, what we're actually looking at generated by NSF is a single page. And we see the project description for that particular proposal is 15 pages. The references were 7 pages long. The bio sketches, which in this case were just of me, because I was the sole PI on this particular proposal, was 2 pages, like I said, limited to 2 pages. The budget is broken up in numerical form by year, and it also has several pages of text justification going along with it. So that ended up being 14 pages total. You can see the current pending support form is 1 page, the facilities and other resources were 3, and all other additional supplementary documents, letters of support, and so forth were the final 4 pages. The 1-page summary would look like this. At NSF, it's mandated that you have an overview, an intellectual merit section that talks about the theoretical and generalizable value of the project and the broader impacts, how others might use the data and the results of this study to improve, how they'll apply it to society to improve, well-being at large in some ways. So how people will use it beyond the specific theoretical content. And then there's that project description, 10 to 20 pages worth. So these are the 3 items I want to focus on first: the project description, this project summary, description, and references. Usually there's no limit to that reference list at NSF. But we'll come back to those 3. Here's the budget page. This is look like a typical spreadsheet. This is called a SIMS form. This is how Penn State prepares this. As you're outlining and developing budgets, when you do it as a faculty member at Penn State, there's a grant office in the college that will prepare these forms with you. So you would meet with a grant officer, you would talk about approximate amounts you want to be in different categories, and they would work this document up and submit it on your behalf to NSF. You have good backstopping in terms of fringe rates, overhead rates, costs associated with these, changes in salaries over time, and so forth. All of those would be figured in the proposal and the direct costs, and then the staff in that office would calculate any indirect costs associated with that proposal. The text justification would then look like this. This corresponds to what we just saw in the numerical charts, but it goes into more detail about wages, who's being paid, why, equipment that might be needed, travel that might be associated with the project, et cetera, et cetera, et cetera. So you have to have this text justification to accompany these numbers. All the same content elaborated in text form. Vita and bio sketches limited to 2 pages with specific headings dictated by NSF in this case, your background educationally, your appointments, your most relevant products, and so forth. Every member of the team would be required to provide this. That's pretty consistent with cross proposal types. This would be a list of the synergistic activities, things that can't fit onto those 2 pages that are part of my CV or background that communicate I'm well positioned to carry out and execute the project being proposed. This is something you'd want to be strategic about, prepare specifically for each research, for each type of funding mechanism you're trying to access. So you don't just use a standard CV or list of synergistic activities. You pick and choose items off of your large, elaborate working CV and put the things in the 2-page version most competitive for that mechanism. The current and pending support form uses a template provided by NSF that looks like this and talks about how many years of support you get from each of the projects you're involved with and asks you to confirm if there's any overlap between projects and so forth. This isn't anything that would ever hurt you. In fact, it can actually only help some cases. Your team is being able to execute a number of projects on related topics and keep them all distinct. So that's often helpful, actually. Can demonstrate, again, credibility and use of funds, the capacity to carry out the projects, but most importantly, also from their side, that there's no double dipping or duplication of research efforts between grants. Continuing through to just to show a visual example of these other elements, here's the collaborator and conflict of interest form, which has me at the top. It has a list of students I've been advising recently, it has a list of my advisors, editors of journals I frequently interact with, people I've co-authored with in the last several years. So it's just a simple table to fill out. This helps them decide who will review your proposal. They don't want your advisors and professors and students or former mentees reviewing your proposal. They want it to be a little bit more objectively evaluated. So there's a reason why they're asking for all of that information. Data management plan, again, talk about the privacy, the confidentiality, security of the data, where it might be archived, where it might be made available, and what form to other researchers in the future that might want to use it as secondary data. NSF and a lot of other federal agencies are requiring now that data sets, at least a portion of them, end up in open access repositories. So it's a good idea to be familiar with what those might be in your research areas. Description of facilities is something that the Penn State Grant Office will often help with, especially for the bigger picture categories here of Penn State or the bottom one, my College of Health and Human Development. Both of those paragraphs were provided by my college. So all I had to add in is a little bit about my department, also a little bit about my institutional partners, field sites that I work in. We get support from the college on this. That's another big advantage of seeking the R1 jobs is they will have grant offices that support your efforts to seek external funds. A grad student postdoc mentoring plan, again, a lot of text here, but how you will facilitate career development and networking, and how you evaluate student and postdoc progress over time. If you care to share it, I mean, a mentoring philosophy towards grad students and postdocs, this is required. Might not be relevant to you now, but it might be in the future if you're a faculty PI on a grant like this. And along with the facilities, what we saw on the previous page, this is a chance to describe the ecosystem around you, whatever institution you're working at. How will you connect your students to other programs? So you can see right there on the page below the words career development and networking, they're in bold. You can see the italicized words, transdisciplinary research on environment and society. That's the dual title program that I oversee. So naturally, when I'm proposing work and planning to fund graduate students in my program, I want to point out that they have the chance to pursue that dual title while they're here. So we describe this ecosystem around them. Penn State has a lot to offer that you can bring to bear and describe in these types of statements to support mentoring for grad students and postdocs. The security plan is a relatively new requirement. This kind of came about in the Me Too era to deal with harassment or falling outs that might occur between staff members, especially when there's a power dynamic between supervisors, PIs, and students and postdocs and so forth. But the pandemic also brought this forward a little bit in terms of a new need on proposals, especially when there's international research involved. So sometimes there's a form like this we have to fill out with that security plan. Managing risks, controlling for liability for the university. Like I said, the pandemic and Me Too really highlighting this. Collaboration letters are not the same as reference letters. In fact, NSF restricts the language that can be used to exactly what you see there if this proposal is funded. It is my intent to collaborate or commit resources as detailed in the project description, the facilities, equipment, or other resources section of the proposal. That's all people can say and sign on to with these collaboration letters at NSF. So if they submitted a longer letter, it would get rejected and not even included with the proposal contents, but they can submit up to this to acknowledge that they're familiar with the proposal and how their institution is represented in that proposal, and they're prepared to follow through as described there. That's a way of keeping, again, the evaluation of different proposals a little bit more consistent and objective. And in addition to, some cases needing to demonstrate the collaboration to get access to laboratories, field sites, certain institutions, and so forth, you have a chance to show off a great professional network here. Finally, reviewers to include, reviewers to avoid. There's a few folks out there that I know have used similar methods, and maybe we've even co-published or written together, but not in the last 5 years. I know they would be sympathetic reviewers and be able to objectively analyze strengths and weaknesses of my project. I can list them if I want to. And for whatever reason, I know there's some other people out there that may not share my view on things. Maybe I've had arguments in conferences with them and in debates where I know their worldview theoretically or methodologically is never going to see value in the approaches that I take. And so I can name them if I don't want them to be there. Interestingly, a few years ago, after I just received notice that a proposal that I submitted and that was rejected but had good feedback that I later resubmitted on the basis of the feedback provided, again got rejected, I was a little dejected. I got that news just before heading into a conference session. At the end of the conference session, I saw kind of a well-known scholar, and they said, "Hey, would you like to go to lunch?" So we went to lunch and we were talking, and during the course of the conversation, the faculty member told me that they had actually been a reviewer on both my proposals and that they thought the second version was worse than the first. That's painful. That's painful to hear when you're trying to respond to a lot of different reviewer comments in a meaningful way. Somebody tells you that you did worse the second time than the first time. But the nice thing is, when something like that happens, you can put that person on your reviewer not to include list if you're submitting to NSF. One of them may or may not be in that list right there. So again, I just threw a lot of stuff at you. You may still feel like this guy standing in the hurricane, but we're still not done simplifying. So bear with me a little longer and we'll get to the questions you may have soon. Out of that long list of elements there, these are the things that you have to gather. Almost all the other things are things that can be prepared in advance. Your VEDA is already sitting there. You just adapt it. Your synergistic activities come off of it. Current pending support is just filling out a form about whatever grant support you have. Collaborators and conflict of interest is the same way. Once you filled that out once, you usually only need to update it every so often. Data management plan, facility description, all of those things that I've faded out a little bit are things that can be developed well in advance and don't always require a lot of processor power to develop. It's these 5 items on the left and the collaboration letters that are really your responsibility. So now we've already eliminated more than half of those elements there. And I put asterisks next to the budget because you can often count on help from your college for that if you're at a research intensive university. Incidentally, they'll also help with the facilities description, the asterisks there. But since you're getting help on those other ones and the collaboration letters are standardized by NSF, it's really these first 3 items that are the most important. And the project summary is just a summary of number 2. And the references are just a running tally of what you've cited with no page limit. So it's really the project description that is the most important element of an NSF proposal. And this is the part that's going to be the same for any funding mechanism you might be pursuing. You're going to have to account for similar types of elements, whether it's an 80-page proposal or a 5-page proposal. So I want to talk about some of those. When you're writing the main proposal document itself, what I'm calling the project description here, you need to start right out of the gates and quickly get to the purpose. You don't spend pages getting into the purpose. You spend 1 page outlining a problem and getting right into the purpose. And I like highlighting, I like italicizing that purpose to make it stand out and pop against everything else being presented on that first page. And I like doing it with the explicit reference to purpose or to research questions. And myself, I like having an overarching research question for the whole project, as well as several sub-questions. So this is the first page of a proposal submitted to NSF. You can see research aims and questions right on the very first page after just 2 paragraphs of identifying the research problem. After the problem's been addressed and the research aims and questions have been brought in, that's when you get into your literature review, the whole background. And I like to think of literature reviews as being about what is already known on these topics. That's literally what they're about. Who else has written about this? What have they said and done? So it's what is already known. And in some of my successful NSF proposals, I've used that phrasing as the headings of my literature review in the proposal. What is known about the human mind and the environment? I go on to talk about what anthropologists have determined about that. Then what do we know about migration and the environment around protected areas? It's almost like a subcategory at the top category. So we're going to start zeroing in on this protected areas idea. Then finally, what do we know about these issues in the Galapagos, my specific research context? So it's almost like a natural funnel, more and more specifically. So feel free to use those headings to make it clear to your reader what you're doing. You're explaining what's already known about the topics so that you can better emphasize what remains to be known. Until I got down to the bottom section there, I wasn't talking about my research setting or context. I wasn't providing specific details. I was talking about the generalizable science about the human mind and environment, and the generalizable science about migration and environment around protected areas. I had not introduced a specific research setting yet. That's one way to make sure you're covering the theory that what you're talking about is generalizable a lot of sites. For NSF programs and those programs interested in pure science, sometimes that's the most important stuff. You can research whatever you want. If you can't explain how it relates back to these big picture generalizable ideas and how it would have value for others, it won't go very far. When possible, you'd like to clearly get to what you're going to contest or confirm using deductive hypothesis-driven work, perhaps out of a positivist tradition. Or if you're doing other types of inductive and exploratory social science, and you might talk about research questions. And in some projects, you could easily have both research questions and hypotheses. It's often very helpful to have a diagram that goes along with those literature reviews that talk about relationships, that maybe establish different viewpoints between the theories, that maybe can show movements or arrows or influences. And in some cases can be used to identify holes or gaps in different disciplines that could be filled by the theory from other disciplines. So I like to think of this in a song analogy. The graphics in some cases are the choruses. The rest of the text is the verse. The verse comes and goes, but you got to have a chorus to circle back to repeat and emphasize to people what the proposals are really about. And graphics are really strong for that. So it's often helpful to have a summary graphic associated with the literature review after a long section of text. And when pages are limited in proposals, you can often communicate a lot in smaller fonts in the graphic than you're allowed to in the rest of the accompanying text. Once you've established the questions based on the theory, then you can start getting into specifics about the method you'll use, the population you'll study, the specific geographic context you might be working in, how you'll operationalize all that theoretical stuff down to a specific study that you will then conduct. So don't do that too soon. Establish it based on the bigger picture theory, and then say, oh, and these methods, population and geography, would be great ways to answer those questions, to test those hypotheses, and to learn more about that generalizable knowledge. So sometimes we start off too soon with the details. We undervalue the theory. We start off the theory and make a compelling case on its basis. Then a lot of different geographic contexts would be good to do that work in. And we make a case for doing it in one particular site. And in some cases, it's because we have some experience or connection to that prior site. But we still have to make the case that it's a meaningful site in which to conduct that work because it allows us to test that theory, okay? And in many proposals, we may be asked to acknowledge our prior experience in the field site. In some cases, we might even be asked to acknowledge our prior experience with the same funding sources. So I submitted an NSF proposal now because I've previously been funded. I'm asked specifically to acknowledge the intellectual merits and broader impacts and resulting publications of the work that was previously funded by NSF. So there's a little example of that there. I like seeing, continue with the methods discussion, the overall design and data collection, being broken up into some phases or something sequential, perhaps. This is the stuff that makes or breaks whether or not you get the funding. A funded grant is basically like a contract that you will carry out the work being conducted. So the more detail you can put in the methods, the easier you make the decision for them to fund you, because they'll know exactly what their money is going to be put towards. You got to have a lot of detail and be as specific as possible about data collection techniques, sampling techniques, data analysis techniques. Don't leave anything to the imagination in the methods and the analysis plans. And you could be citing even within those to rationalize your research design, the data collection techniques being chosen, the analysis techniques being chosen. Certainly do that. Those are like chess pieces you put out in front of you to protect you, the king and queen of your proposal, so that people can't critique you without going through these people you've cited that have already made the case for you. Again, like having graphics to summarize the use of the methods. These two tables are from two different proposals that were both funded at NSF, but you can see they're similarly formatted with columns that relate to phases or scale, data collection efforts, data analysis efforts, how those link to the overall purpose and the products or outcomes being sought by those different techniques. So a graphic like this that summarizes the research design and methods is really, really helpful, especially if reviewers are looking at a lot of proposals one after the other. The text can get dizzying after a while. Having, again, a chorus that they can circle back to, see in a quick view, a quick snapshot view, what you plan to do. And it gives you a chance to reiterate what's in the text, to repeat it in a different format. So that's how it can become part of this chorus, this song of the overall proposal. And I don't leave the methods without explicitly revisiting those research questions and hypotheses, how they've been clarified. So I walk right back through those research questions, phrased identically to how they were phrased earlier, and explain what we'll now know once those methods have been carried out. That's another way of repeating and circling back to important elements and keeping a little consistency across the proposal. To see those questions represented, same format with the analysis plans under them and how we'll know when the questions have been answered or the hypotheses have been tested. We'll almost always need to include a timeline, a calendar. This is a format I've used on many, many proposals. It's broken down by years vertically, and from left to right, it goes by months. So the letters there represent the months of the year, starting with September, October, November, December, etc. The academic years, basically, and different activities. And this has to be highly consistent with anything described in the rest of the proposal. So there's a little bit of text there that explains the overall plan, but then there's a lot of detail in that graphic. And lastly, at NSF, the main review criteria are its intellectual merits, the theoretical value, what's generalizable, and the broader impacts, the value beyond academia, the value beyond specific research itself. So circling back here, again, a lot came at you. What I want to highlight is what we just talked about. This project description is the critical component. You got to identify a problem. You got to talk about what's already known about that problem. You got to use that to identify questions or hypotheses that you'll add that are novel and new. You want to have methods that allow you to answer those questions or test those hypotheses. You want to have an analysis plan in particular that ensures they get answered well. And then you want to explain, what will it mean going forward and who will benefit from it. So to just put a visual metaphor to this, if you begin working on this proposal and you add in one chunk here and one chunk there, and you don't address, you don't provide a timeline and you don't provide an analysis plan, then there's going to be gaps. And when your proposal is compared against other proposals, it's going to be really clear where the gaps are. They spent a lot of attention here in the literature review, but they didn't really detail the methods. Or they wrote a lot about the methods, the data collection techniques, but not the analysis techniques. We don't even know how they're going to use that data. It's really obvious to reviewers when there's missing elements. So what a better strategy is to make sure you add a little bit of content in every part of the proposal. And in some cases, if it's a short proposal requirement, 3 to 5 pages, you might not be able to get much more than a little bit of content on each one of those elements. But you're better off making sure you've addressed at least every element than you are trying to add a lot of content to some elements the expense of others. And if you have a lengthy proposal and you're really efficient with your writing, then you can sometimes fill it all the way in. But this tree image on the right is a good metaphor for how to approach proposals. You want to make sure you have touched each of the expected elements first, and then as you're able, add in as much detail as the page lengths will allow. And that's true whether you have 80 pages or not. That's why these elements are consistent across proposals. Sometimes you only have a few pages, so you're only putting a few leaves on that tree. Sometimes you have many, many pages. And you can really fill that tree up with leaves. You got to try to keep in mind the reviewer and what else they will be doing. Usually looking at a lot of other proposals right alongside of yours. So you don't want to do anything that makes yours stand out in a bad way. You want to give them all the expected elements and not leave any one of those out. Okay. Just a few other quick bits of advice. Just get to doing this. Get to doing a lot of proposals. Fail. Failing's fine. Failing's how you learn. You won't get better at it without doing it. So find as many opportunities to prepare funding proposals as possible. And, failure is directly correlated to success. Ask Michael Jordan. He missed more shots in the NBA than any NBA player. He's also the most celebrated player of all time. If you're not sure where to begin, talk to your advisors, find out the people that are really active in funding, finding funding externally, funding in particular, and just see if you can join them, learn from them, see their proposals, try to keep up with what they're doing. In some cases, you may very well have the opportunity to be a reviewer for grant proposal programs yourself. At NSF, I asked if I could get involved with reviewing those doctoral dissertation awards. And after a few rounds of doing that for individual proposals, I was invited to be on a panel, faculty reviewing a bunch of those proposals at once. And that led to more and more reviews of senior faculty proposals and eventually onto proposals for faculty grants. So that can be a bit of a domino effect over time. It is simply the best way to see what works well and what doesn't, what kind of mistakes can easily be avoided by seeing people implement those mistakes in their proposals, but also the good practices that they have. And a lot of times you see formatting and tricks, how to present a lot of stuff in limited space. You see good ways of going about making graphics, how to make the things legible. So you learn a lot of good practices by reviewing grants, see if there's not a chance to do that at the earliest possible moment. Another one that's students often have a challenge, are often challenged with, is dreaming big about the projects. A lot of times students feel like they need to try to propose as little money as possible so they can, make sure the project's feasible. And I would say that's not really how good science is done. You got to know what you would do if you had $50,000 or $100,000 or even $500,000. You never know when some donor is going to be walking across campus or in your research site. They're not going to point out what you need to do. It's your responsibility to point out the meaningfulness of the research and the topics you want to explore. And so whether you're pursuing a big funding mechanism or not, you always want to have at least a few ideas about how you might pitch your research to somebody with that kind of money, whether it's an individual like a donor or a funding mechanism like an NSF. So think about that. What if money was no limit? What if you could hire a bunch of assistants or a bunch of grad students or even postdocs or buy new laboratory equipment or contract undergrad assistants? Don't be afraid to ask for what is necessary for the project to be carried out in a meaningful way. It's really the only way to acquire large grant amounts and be successful by, R1 large university standards. Don't be afraid to ask for the bigger money, dream bigger. And then lastly, the brain is split into different sides that have different strengths. You can see on the left side, it does all the analytical, orderly stuff, the logical, it's good with numbers and language, whereas the right brain is a bit more creative and imaginative, emotional, intuitive, and so forth. If we compare that to what we just saw, this side is going to be good for all the organizational stuff, the number crunching, the stuff that's really pretty straightforward. It doesn't require a lot of processor power. It's really just organizing and getting things into the right place. The whole other half of the brain is the creative element, putting the project description itself together, the main proposal document. That's where you have to creatively put together theory and methods into research questions and have it all make sense for the readers. So I often move back and forth as I'm preparing proposals. Sometimes I'm focused on the creative side until my brain gets burnt out. And when I get burnt out, I know I need to take a break, but I can't stop because there's a deadline coming up. So I jump back into the other brain and I start fixing my references or my Vita or reviewing my budget justification and so forth. So you can move back and forth between these tasks and keep the different sides of the brain from getting too exhausted. And then, keep an eye out for these science communication workshops around campus. As I mentioned earlier, get familiar with how to make a good pitch for funding, get good at these elevator pitches as we talk about them, even in entrepreneurial circles. You may need to have a different message depending on who you're talking to. It could be a layperson donor. It could be a scientist at the National Science Foundation. It could be undergraduates. It could be your research participants. Learn to adapt the description of your research to different audiences. Different things will need to be emphasized in those cases. And remember, that's how you learn, communicate science, whether it's in 80 pages or a few short pages, learning how to craft the message appropriately. Compass is an organization that's been to Penn State campus to offer science communication workshops through what they call this message box workbook. This is something maybe a student organization might want to look into, perhaps even use UPAC funds or something to invite some Compass folks back to campus for training. But there will be lots of other opportunities for science communication training, online and at conferences and so forth too. So boom, that was a whole lot. We talked a little bit about these different types of research, pure versus applied in particular, and different funding sources for that. But at the end, they have common elements to the proposals. And out of all the different contents in that proposal for NSF that we reviewed, it really is the main project description that's the key element. And those contents have to all be represented, whether you only have 3 to 5 pages to do it or whether you have, the 15, 20 pages to do it. So that's the idea of putting the leaves on the tree. And then I shared some additional advice there at the end. And that's a lot. So I will pause there then and be happy to answer more detailed specific questions.
Thank you very much, Dr. Hunt. Can you hear me clearly?
Yes.
Okay, so thank you very, very much. I'm sure we all have reactions, and since we're not in a room, let's use the reactions tool. I've particularly
I'll leave this
gained.
up just in case we need to scroll back through anything.
Okay, all right. So yes, I particularly gained so much from this session, and we've garnered questions actually. So we put up the platform. Let me just repost that so that just in case someone just joined in, they can ask their questions. So thank you very much. The first question I have here is, how do we develop the interdisciplinary insight as an early career researcher to be competitive, since some funding agencies prefer collaborative projects? I can take that again. How do we develop?
That's okay. That's okay. That's a great question. And it's one that's specifically challenging for graduate students who are necessarily, by definition, doing a relatively independent dissertation. And yet maybe being encouraged to be as interdisciplinary as possible with that. We can't all be masters of every discipline, no matter how much effort we put into it. So, here's a few things I'll say about that. One is, you will necessarily have to focus. You may be more limited in what you can do in terms of interdisciplinary work as a PhD student, because it's you largely being held accountable as an individual for your work. But just remember, that won't be the last project you ever do. And ideally, it's the first of many, many projects. And once you get that PhD, if you didn't like it, you may never have to work alone ever again. Surround yourself with all those other teammates that may be the great statisticians or the great designers or the great theorists in different areas. So, there's certain limits to how interdisciplinary, transdisciplinary a PhD student can be. But funding mechanisms that are directed specifically at PhD students will take that into consideration as well. They know you can't do it all. So some of the things they're looking for is what you borrow, where you reach into those other disciplines. Do you pull in a little bit of the theory from economics or from geography if you're a sociologist? So you can represent different disciplines in the theory. You can sometimes borrow methods from the other disciplines as well. If you can use methods that haven't been used in one setting, one context, that's a way of bringing in some methodological novelty, but the methods can be interdisciplinary. In the meantime, while you're stuck being a student and necessarily a little more focused on a single discipline or a smaller set of disciplines, look for opportunities to join bigger teams at Penn State. There's always research teams looking for a little extras, data collection, data entry, data analysis help. So see if there's a faculty member working on bigger projects. See if you can sit in and listen to those. What are they doing to be competitive in your different areas? Even if that's not your dissertation, do a lab rotation with somebody and find out how they deal with that. Well, in our transdisciplinary trees program, we don't only want different disciplines, we want non-academic stakeholders. That's how we define transdisciplinary. We have the different disciplines, but we also have somebody that's not from a discipline at all. It's from outside of academia. In some cases, you may have a partner organization you're working with and may be able to describe what you're doing in the language of transdisciplinary research, whether you realize it or not. So sometimes it's just learning to apply the language where it could be applied more so than it is actually doing things in a distinct way. But that's challenging. All the disciplines have their jargon and their language and their traditions for describing.
Yes. Thank you very much. Okay, so the next question is, actually this person's asking if you can share this detailed document or if you have any resource you could share, but particularly they asked for this document.
I think I can. I may have to review a few things in there,
Okay,
but potentially, yes.
thank you very much. Okay, so the next question is, apart from NSF, what are other funding sources that are common for pure sciences based on your multidisciplinary work?
Yeah. Well, I mentioned a few of the big federal agencies. Here at Penn State, we're housed, my department's housed in the College of Health and Human Development. So the biggest funder of the College of Health and Human Development research is the National Institutes of Health. It has many, many funding mechanisms for different career stages, some stuff for students, some stuff for postdocs, senior faculty, multidisciplinary, multi-institutional projects and so forth. So a big range of programs there. And for my other colleagues that are in geography that may be doing some sort of spatial science, NASA, which oversees the whole satellite network, provides satellite imagery that they remotely analyze, that they do remote sensing analysis on. NASA could be a partner organization that provides funding in some cases. Penn State is a Sand, Sun, Sea, and Space Grant program. There's a space grant fellowship for graduate students at Penn State if they have those types of components in their research. There are Department of Defense stuff, especially a lot of engineers and certain types of energy technologies are often cases getting support from the Department of Defense. And there would be a few private foundations. In my department, there's a few of us that have submitted proposals to what's called the Templeton Foundation that focuses on a lot of things like character development and so forth. There would be other foundations focused on specific goals like youth development or obesity prevention, active lifestyles, and so forth. Sometimes there's these niche foundations. And that's, again, a good question to ask the advisors in your respective disciplines is, what do they consider to be the primary funding mechanisms? Maybe you want to get a little database going for yourself. There's one that I used to share with students. It's where anthropology graduate students could seek funding. It was a handful of dissertation level funding sources. So there might be something like that already in circulation in your programs and disciplines. You might ask other grad students or the faculty, and if there isn't, get one started. People will really appreciate that.
Okay, thank you very much. Okay, so the next question is, do you serve on dissertation committees for students in pure sciences?
I serve on a variety of dissertation committees. I would say everything at the dissertation level is probably pure science. If you're doing a PhD, that's a research-based degree, you must be producing some generalizable novel content. I would consider a PhD to be pure science in almost all cases. PhDs could also have a certain applied component to them as well. But I think, unlike other forms of research out there, a PhD in particular is designed to prepare somebody to do that applied science. I'm sorry, to do the pure basic science.
Okay, so I think maybe the person means like physics, chemistry, and whoever sent in the question can, explain what they mean directly, but maybe they mean the classification, biology, and all of that.
Yeah, I would be careful. I would caution folks from associating pure science with just the natural and traditional hard sciences, so to speak.
Yeah.
The social sciences have made incredibly important contributions, and they don't all use the same traditions, but they're based on empirical observation, long traditions of research that are constantly evolving. So those social sciences do have some distinctions from the natural sciences in some ways, but the science part, not the part that's distinctive. Sometimes the approaches and the methods are a little different. So that's not the distinction I was hoping to make. I was just making the distinction between pure and applied sciences. And I brought up the natural and the social sciences because there's some paradigmatic differences there. I tend to serve on committees in the social sciences. I have been on committees of faculty, of students from diverse programs like international ag and development. That sounds like agricultural sciences, but it's got a social component. at the ways that agriculture supports community and human development. I've been on architecture committees. That's a design-oriented field. That's almost like a third element. We often say social science, natural sciences, in some cases, the design fields like engineering and architecture. I've been on some committees over there when the student, was looking for some support on the social science side. But for the most part, most committees I've been on have been geography, anthropology, see a lot in my home department here, recreation, park, and tourism management, where most of my students are working in ethnographic techniques, lesser developed settings, parks, protected areas, biodiversity sites. So
Okay, thank you very much. Okay, so the next question is, with the current political landscape, what is a good strategy to make sure red listed words are avoided, even though they are essential to the study?
well, this is where some colleagues in places like Florida and Texas have a big head start on us because they've been dealing with initiatives at the state government level that have restricted the use of certain language, for instance, around climate change or critical race theory in particular. And language is fluid and constantly evolving. And the bureaucracy needed to implement those particular policies to reduce certain language. I'll never be able to keep up how fast language can evolve and change. So even though I don't agree with a lot of those efforts to restrict language, there are always ways to creatively talk around certain words and terms. And I know there's a lot of international students here right now. I'm sure many of you master several other languages. As you know, in some cases when you're talking another language, you don't always know the word you're looking for. You learn how to talk around that word with the words you do know until that word becomes known. So that's something we do out of necessity sometimes. This is the case where we could do that on purpose, not because we don't know the word, because we know that word could be a bit of a trigger. And so sometimes you can talk right around the words by mentioning, damage from extreme weather events, as opposed to climate change, something that might be a trigger word for certain political, positions out there. So there's ways around that. All academics are getting creative, and some of those states, if you have colleagues or friends there, people that have been working in those contexts, those might be good people to ask about, how they've dealt with sensitivity around particular words.
Okay, all
It's
right.
all back to the messaging as well. If I am interested in a project about biodiversity, that's really my passion. All the research I do is designed to understand how we can protect biodiversity better. So whether I talk about community development because I'm proposing a study that I want to see if a community development-based organizational fund, whether I'm talking about tourism because these private sector interests might want to fund tourism research, or whether I'm talking about something anthropological because tourism involves a mixing of cultures, I can take my interests and frame it in the different language, the different theoretical perspectives. So I can do that as well if I need to avoid words that have been politicized. Doesn't mean I have to give up on the research interests. It might mean I just need to frame it and communicate a little different.
Okay, thank you. So the next question we have to close out the questions now because we are over time.
Yeah.
So I have one more question after this. The first is, what are some tips for writing winning proposals and for graduate and postdoctoral fellowships? So I know we had an entire slide on this, but just in case there is something you would like to add to that for this person.
The best tip is the same tip that would apply to cooking well, to writing well, to speaking a new language well, is that just look for as many opportunities as possible to do it. Don't put your eggs in one basket. Don't take the sniper approach, which might not be the timeliest example, where you're just trying to hit something with a single bullet. Use the shotgun approach or the net approach. You're not fishing for a single fish. You're putting a net out, and you're trying to access as many funding mechanisms as possible. It's really common for faculty members to have many proposals under review at any given moment because we never know which one will come in. Do not worry about what you will do if they all come in at once, because that's the best possible problem. And your faculty, your advisors, your department will help you deal with that if need be, and help you with the resources like teaching releases and so forth to allow for that if that's what ends up happening. But just by doing it as much as possible, applying, seeking feedback, some type of feedback you'll get from the experts at NSF that have reviewed your proposal or other funding agencies like that is as detailed and as valuable as you'll ever get. They are experts on that topic area or on those methods. So ask for the feedback if you don't automatically get it. See what you can learn there. Not every program will provide the feedback, but a lot will. And even a little bit of feedback can be helpful about, what sank the project, or how did I miss the fit with the funding mechanism? What can I do better the next time? That's it. Learn by doing.
Okay, so the final question, thank you. What is the best strategy to present a project idea to potential collaborators while protecting the idea's confidentiality?
That's an interesting question. Picking carefully which collaborators you present it to is probably going to be a big part of that. How trusted are they? That's probably a good academic practice, is have a few people that are good sounding boards for you to bounce ideas off of. Sometimes it can be helpful if those people aren't right in your discipline alongside you, because a lot of reviewers may know about your area, but may be doing things a little bit differently. And so you want to make sure that the way you're communicating ideas is clear. Sometimes that can be made more evident when you talk from people a little bit outside the discipline, where you're not assuming jargon is really well known between people. I feel like that might be a good question for, Penn State. Here we have some commercialization offices that deal with patents and intellectual properties that can result from our research projects. There may be some people out there able to provide good advice along those lines. Sometimes in the social sciences, we have to deal a lot with anonymity, protecting the ideas and those we've accessed, gathered data from. That's a little different though than protecting the idea itself. So that might not be a question you bring a whole lot to bear on, actually.
Okay, so yes, I think that's the Office of Research Protections. You might want to reach out to them, whoever asked. So thank you very much.
There's also a commercial, it's like a commercialization office that will take the products of research and help researchers commercialize those. Say it's a new business idea and they want to create an entrepreneurial business opportunity and sell that as a new product or something. So that's out in Research Park. That office may have changed names a bit over time, but it's something about commercialization of research projects.
Okay. All right.
The Office of
Thank you.
Research Protections is often about protecting the participants of the research, making sure subjects involved in research aren't harmed in any way.
All right. Thank you. So I'll be handing over to Mr. Ezekiel to take us on for the next segment as we wrap up.
Okay.
Thank you.
Thank you so much, Dr. Carter, for that wonderful presentation and for also giving your insights to the question. We appreciate you. Thank you so much.
Sure. Hope it was helpful. Good luck,
Yes.
folks. And maybe if we need to, we can follow up, you and me, Ezekiel.
Yeah. Thank you so much.
Good luck, everybody.
All right.
Happy hunting.
All right. Yeah.
Cheers.
So we've come to the end of today's webinar. I want to thank you all for waiting till the end up to this point. And not to take your time, this is the first of many webinars we're going to have from Springboard. What I want you to do, if you've not followed us on LinkedIn, I want to encourage you to please go on LinkedIn right now and follow Springboard SC on LinkedIn for more updates, as we'll be sharing some more updates on the next webinar. Again, this is Springboard. We want to impact the community. And one of the big program or project we have coming up is the research competition to, welcome applications from different folks here in Penn State College, doing research that is impacting the community. So we are currently planning a competition coming up, and more details will be shared on our LinkedIn. Once again, thank you everyone for attending, and we hope to see you next time on our webinar. Thank you so much. Have a good day, everyone.
Bye.
Bye.
Thank you. Bye.